Hello friend, in today's session we will learn how to simulate the LCD and LM35 with your Raspberry Pi on your Proteus software. So in this session we will see how to create this type of circuit as soon as the final source code. So I request you to watch this complete video so that you can get idea about the circuit diagram as soon as the source code. So let's see what will be the final output first. So when you run your Proteus software, you can see there is first welcome message comes on LCD, and then temperature, and whatever the temperature you have given in LM35 sensor, that will display on here on LCD. So once you increase the temperature, you can see that temperature also increases and display on the LCD. So once you decrease the temperature also, the temperature also decreases on LCD. So before starting the actual explanation, if you haven't installed the Proteus software on your laptop, so please watch my first video on Proteus. The link of that video is present in description. So let's see how to create a new project in Proteus software. So you can see Proteus 8 Professional icon is present on your desktop. Right click on that icon and click on Run as Administrator. Be specific. Click on Run as Administrator only. Then click on Yes. Once you click on yes, the Proteus 8 gets started. You can see Proteus Design Suite 8.9. You require 8.9 for Raspberry Pi. Then click on New Project. Then give your project name here. Let's see LCD with Raspberry Pi. Then after that, provide the path of your folder. Let's say I have to store that project on desktop. Select that folder. Then click on Next. Then create a schematic. Click on this symbol. Next. Do not create a PCB layout. Like next, create a firmware project. Then in family you have to select Raspberry Pi. Click on next and click on finish. So once you click on finish, you can see there are two windows open. One schematic capture and second one is source code. In source code we have to write our code, and schematic we have to create our schematic. So you can see ready-madely Raspberry Pi is already present on your Proteus software. So our target is we have to first create the LCD schematic. So to select the LCD, first go to this component mode, then click on P, then type here 16 cross 2. Then you can see LCD 16:2 alphabetical. This you have to click on OK and place here. Then next part is we have to take the ADC IC, because Raspberry Pi does not have the inbuilt ADC. So ADC IC is MCP 3208. Then click on OK and place here. Then after that you have to you require LM35 temperature sensor. Then go to the component again, then P, then LM35 and select LM35 here and place here. So all needed component we already selected and place in our Proteus software. So next part is we have to connect LCD to our Raspberry Pi. Basically LCD works on the GPIO protocol, so we need a GPIO pin from Raspberry Pi. You can see there are number of GPIO pin. You have to select any of these GPIO pin. So first is we need to we need to add the ground on LCD. So go to here in terminal mode, then click on ground and place ground here. Then VDD pin is nothing but ground pin of your LCD. Click on this. So ground is connected to your LCD. Then this LCD with Raspberry Pi we will interface LCD in 4-bit mode. So we require only 4 pin from LCD. So the 4 pin is D4, D5, D6 and D7. So if you want to connect this pin with your Raspberry Pi, then go to this terminal mode and click on default. Then you can see this pin will appear. You require 4 pins. So once you select the 4 pin, then click on any one of this pin and click on rotate clockwise, anti-clockwise. Then place in front of D4. Then second pin again rotate anti-clockwise. Then D5. Then third pin, rotate anti-clockwise, then D6, rotate anti-clockwise, and then place here. So once you place here, you have to connect D4, D5, D6 with these pins. Okay, one by one you can connect this pin. So once you connect, you have to give the name of this pin where you want to connect. So D4 we have to connect on GPIO 4, D5 we have to connect on GPIO 17, then D6 we have to connect on GPIO 18, and D7 we have to connect on GPIO 27. So give this name G4 17 18 name on this pin. So double click on this pin. So once you double click, you can see there is string will happen, and in this string you have to give as it is name GPIO 4. Then next is GPIO 17. Then next is GPIO 80, GPIO 18. Then next is GPIO 27. So this is mean that GPIO 4 pin is connected to GPIO 4 pin from Raspberry Pi virtually. So you will not require manually connection here. So this is very simple way you can connect any one of this pin to any one of this terminal. So next part is RW pin. The RW pin of LCD should be connected to ground. So this should be connected to ground permanently. Okay, so next part is you have to connect RS and enable pin. So RS pin is connected to GPIO 22 number. So again go to this and select default, place here anti-clockwise, and place here. We can shift this pin to little bit below. Okay, then we have to connect RS pin to 22 number. Then double click on here. Then give here name GPIO 22. Then we have to connect enable pin on 23 number. Then again go to this and select default and take any one of this default pin and right click anti-clockwise. Same procedure, connect this one, give here name GPIO 23. So you can see we have successfully connected LCD with your Raspberry Pi. So next part is we have to connect MCP3208 ADC IC with your Raspberry Pi. This ADC IC works on the SPI protocol. So we have to connect SPI pin from this ADC IC to SPI pin from our Raspberry Pi. So again go to the terminal, take default, select 4 pins side once and select all this pin and rotate 180-degree. Again select all this pin and place here. Now you can connect all this pin one by one. So you can see clock pin, Raspberry Pi we have to connect clock pin. Then double click here and give name as it is from Raspberry Pi. You can see there is clock, so CLK. So next part is D in pin, that is input pin from this IC. So there should be D out pin from Raspberry Pi. The D out pin from Raspberry Pi is master out slave in. So give here name master out, that means Raspberry Pi send signal, and slave in, that means ADC IC take the signal. The next part is D out pin. So D out pin from this means the ADC IC send signal and Raspberry Pi take this signal. So click on here and you can see here is a MISO, that is master in slave out. Master means Raspberry Pi, slave out means ADC IC. Give here name MISO. Then next part is CS pin. From this ADC IC you have to connect CS pin to Raspberry Pi. So you double click here and give name as it is CS. Okay, so this means your ADC IC successfully get connected with your Raspberry Pi virtually. Now next part is we have to take the LM35 sensor. Then again go to the component mode, then click on P and type here LM35. So once you type LM35, you can see LM35 pinout get open. So select any one of this and place here. So once you place here, you have to first connect, first see the 1, 2, 3 number. What is importance of this number? So go to the Google and type here LM35 pin out. So you can see the first number pin is nothing but the VCC pin which require 4 to 5 volt. So you have to give the first number to VCC. Then you can select the power supply. Go to here generate mode, then DC, because these pins work on the DC. Place here and connect this pin here, and after that you have to give the 5 volt input. So double click on here and give 5 volt or 3.3 volt. Then after that you can see here next part is second one is out pin. So this out pin nothing but this temperature sensor sends some signal, and this signal should be captured by ADC IC. So you can you should connect this second pin to channel 0 of ADC pin. So to connect this pin, again go to the terminal default, then select this pin, right click, rotate 180-degree shift, connect this pin, and after connect give a name again second default, place here, then you have to give common name between these two pin. So we can give here ADC 01 or ADC 00. Same name should be here ADC 00. So that's mean these two pins get connected each other. Now last pin, from this pin you can see last pin is nothing but the ground pin. So you can take the ground from terminal mode, then ground, and place this ground here and connect this ground to this pin. Now the next part is we have to connect V reference and analog ground of MCP320 IC. So if V reference is nothing but a VCC, so you can find the VCC pin in generator mode, then click on DC and place DC here. So once you place DC here, click here and connect to V reference. Then after double click here and provide voltage to 3.3 and click OK. Now you have to connect ground pin. So if you want to create ground pin, go to the terminal and then ground, then select here, place here ground and connect ground to here. So in this way we have successfully completed the circuit diagram of our project. Now next part is we have to take the code. So if you want to write the code in Proteus software, go to the source code and here you can write your own code. So I will open my code first. So before starting the next part, I request you please subscribe my channel. You can see there are many views comes on my channel, but there are very less subscriber 114 only. So you haven't pay any cost to just click on the subscribe button, but it will definitely it motivate me to create a new video like this only. So please subscribe my channel and please support me and please comment on each and every video. So in source code you can write your own code. Then I will open my code, paste this code here. So we can see importance of each and every line from this code, so that you can easily get understand working of LCD and LM35 with Raspberry Pi. So let's see the first line. So first line is nothing but input SPI dev. So SPI dev is basically SPI library which is used to access SPI pin from Raspberry Pi. So next line is import time. So if you want to create any delay in your program, you can use the time library. Next line is import OS. If there is any OS function, you can use this library. Then next line is import Raspberry Pi.gpio or GPIO. So if you require the GPIO pin from Raspberry Pi, you need permission. So with this GPIO package, you can take any access of GPIO pins from Raspberry Pi. So this is repeat line. So next line is GPIO.set mode GPIO board. Basically Raspberry Pi works as a 2 meter as a Raspberry Pi board or Raspberry Pi BCM chip. So if you want to create if you want to use Raspberry Pi as a complete board, so you can use this line. Then next line is GPIO.set warning to the false. Whenever you run the code, Raspberry Pi give warning that The GPIO pin whatever used is already used before. So to avoid that warning, you can set GPIO.set warning to the false. So next line is equals and yield delay. This basically the variable which is used to create delay. We will see later what is use of this variable. Send delay one, it is again the variable. Now okay, now next point is they define the LCD pin. So you can see LCD RS pin is connected to 29 number as per the code. Let's see the schematic. So in schematic we have connected RS pin to 22 number. You can see here GPIO 22. So this GPIO 22, but this GPIO 22 is nothing but the BCM chip number. We have selected Raspberry Pi as a board. So on board it is 15 number. So you have to go here and change 15 number. Now next part is LCD enable pin to 31 number. So enable pin as per schematic we have selected 23 number. So here 23 number, but as per board it is 16 number. So give here 16 number. So next part is D4 pin, that is GPIO 4 pin. This is connected to GPIO 4, that is 7 number. So here should be the 7 number. Then next part is D5, that is connected to 17 number. So here is 17 number, that is 11 number as per the board. So you can see here 11 number D5. Then D6 is 12 and D7 is 13. So you can see D6 is connected to 18 number, that is 12, and D7 is connected to 27 number, that is 13. So as per the code we have connected all these pin. Now next part is we have to set that all this pin, that is Raspberry Pi pin, as output pin, because Raspberry Pi sends signal on LCD pin. That means that GPIO pin work as output pin. So declare that pin as output pin. You have to use this syntax GPIO.set mode pin name, then GPIO.out. So in this case all these pins are our output pins. So we have set all this pin here as output pin. So next part is define some device what is the length of your LCD, that is it is 16 by 2 LCD. So that we have selected here LCD width is 16. Then character to LCD command is called. We will see the use of this variable later. Then line number 1 is 18, line number 2 is C0. So if you want to send some signal on LCD on first line, that is 16 by 2, there are two rows, first row and second row. So if you want to send on first row, you can use this syntax LCD 80, and if you want to send some signal, that is some message on second row, you can send C0. So we will see later what is use of this variable. So first line what is executed in program is LCD init function. So you can see LCD init function is here. So here first one is LCD init function. In LCD init function we have to send some command so that our LCD gets work. So this command thing but start the LCD, take the initial to first row only, message should be printed on first row only. All this command you can see all this command, and you will see you will get details of this command on Google. You can search the LCD command, you can easily find the importance of each and every command. So main important part of this is to how to send this LCD command from Raspberry Pi on your LCD. So there is function lcd.byte. Then you have to pass the command and LCD command. So the LCD command is nothing but the variable we have declared already here, LCD command to the false. So we will see this what is this function. So LCD command, it is jump to this LCD byte. Then after that here is select GPIO.output LCD RS pin mode. So what is mode? We have sent here mode as a LCD command. So means this is the command mode. So whenever there is a command mode, you have to select RS pin, and that RS pin should be the Raspberry Pi should send the 0 signal on that RS pin. So you can see LCD command mode, this is variable, and this variable has a value false. So whenever you are sending the command on LCD, you have to send RS to 0, that is RS 0 signal on RS pin. So that we have already created function LCD byte send command and LCD command. This is nothing but 0 automatically send on RS pin with this function GPIO.output LCD RS to 0. Then after that we have to send the data. So data is nothing but this is a 8 byte of data. You can see this is by 8 byte of data. But in our schematic we use the 4 byte pin 4 pin. So we have to segregate our data into 4 byte, so that we use another logic. So once this signal 33 number sent to LCD byte, it comes here. Then first part is set the command as a command mode. Then GPIO dot output, all these our 4 pins should be selected to false by default. D4, D5, D6, D7 should be the false. This means that the zero signal sent on the LCD D4, 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 D5, D6, D7 by default. Then next line is if bits ending with 0 1 0, that is higher byte is equal to 1 0. So let's say this is 33 number. If you so first we have to send the 33 number 33 data or command on LCD. So in 33 we have to first aggregate the higher byte first and then lower byte first. So you can see this is our higher bytes and this is our lower byte. So from the higher byte we have to send the D4 first. So to send the D4 byte first, we have to masking with 1 0. So after masking with 1 0, you can see the D4 bits get one value. So if that value is 1, then we have to send one signal on D4. So that one again shifted to the D5, then again masking with 2 0. And if the value is 2 0, then we have to send the one signal on fifth number of LCD bit. So this logic applied to each and every pin D6 and D7. So once this higher by bits get executed, say on LCD, we have to shift the same logic to the uh, lower bits. So again lower bits we have to send D4 first, then D5, D6 and D7. But in that case the masking is 0 cross 0 1. So we will see the code. So first we are sending 33, then the LCD bytes get here. Then 33 mode is command because we are sending command. Then GPIO dot output LCD RS pin to the mode, that is mode is command, that is 0. That means 0 signal send on the RS pin. Then by default we have to send the 0 signal on each and every pin D4, D5, D6, D7. After that we are checking is first bit masking with 1 0 is equal to 1 0. If 1 0, then we have to send D4 to the true. If that is not equal to 1 0, then we have to already send false signal from here. Then second bytes from the higher bits 2 0. If this value is 2 0 after masking, then we have to send D5 to true. Then third byte 4 0, then D6 to true, and then last byte D7 byte. If when masking is 8 0, then we have to send D7 to true. If any of this condition false, then we already send the false signal. So once you send the higher signal, you have to toggle the enable pin. So to toggle the enable pin, we are using this logic LCD toggle enable. So in that logic, we have to pass the high low signal on the enable pin. So to pass the high low signal, this is the logic time dot sleep. First we are sending some delay. Then GPIO dot output enable pin to a true. So it will send high signal on enable pin. Then time dot sleep to the pulse. Then it is sending some time sleep. Then GPIO dot output LCD enable pin to a false. It is sending the 0 signal on LCD enable pin. Then after some delay, so it will toggle the pin. So once you send the higher bits, we have to send the lower bits again. So same logic will apply. First we have to send the 0 signal on each and every pins D4, D5, D6. Then again masking with 0 1. So in this case is 0 1. We are first masking it 1 0 because it's higher bit, and this is the lower bit because this is lower bit, we have to send 0 1. So if the value is 0 1, then we have to send LCD D4 pin to the true value. Same for the D5, D6, D7. So in this case we are sending the data on LCD pin. After sending the data lower bits, we have to again toggle the pin with a toggle function. So this is the basic idea behind how to send the data on LCD. So once LCD get initialized, the next part is we have to send the welcome function, welcome message on LCD line number 1. So we have already defined LCD line number 1 variable, which is nothing but the 0 value. So LCD dot string welcome. So welcome is nothing but the array. So each array is divided into again 1 byte with their index. So index 0 contain W, index 1 contain E, L contain second index, then C. So this iteration we will do with by the for loop. So first go to the LCD string function. So inside LCD string function there is a message that is welcome and line is line number 1. So first we have to calculate the width of that message with this function. So once you calculate the width, we have to uh, we have to tell LCD that this is this message has to print on line number 1 by using this command, line command. So line command get execute with LCD byte, same logic will after same logic will execute. Then next is we have to iterate the welcome message. To iterate the welcome message, we will use for loop for I in the range of LCD width. So I is not starting with 0 and it incrementing 1 2 3 4 till LCD width. What will be the length of this message? So let's say first I is equal to 0. So LCD byte function get execute with parameter message of I. So I is 0, then message of I is 0, nothing but the W. Then LCD character. Then we are passing the character to the LCD byte, so that LCD with so that RS pin set to 1, and then our message get print. Once the W is sent on the LCD, we have to send the E. So I increment to 1, then E will send, and same with the same logic all the message send on the LCD. Now once your LCD welcome message print on line number 1 on LCD, we have to send the temperature data on LCD. So to send the temperature data, we will use read channel and convert temperature function. The how this read channel convert temperature function work, I already told my in LM35 video. Please watch that video. The link of that video present in the description. So once the temperature data gets calculated, the data is stored into temp variable. Now we have to send the temp data into LCD. So next line is LCD dot string temperature on line number 1. So temperature will display on line number 1. Next line is LCD dot string of temp. So this is nothing, this temperature is nothing but the integer. So whatever the data present on LCD is nothing but the character. So to convert that integer number into character, we will use type casting operator. So this is nothing but the type casting. Then we have to send the data on line number 2. We will use this command line number 2, and then our temperature data gets printed on line number 2. So after that, once you run your code, you can see welcome message printed here, and after some delay temperature also print here. So we have successfully uh, run the protest simulation of temperature and LCD of Raspberry Pi.